Hi, welcome to Mrs. Park's geometry class. This is chapter 2, section 5, postulates and paragraph proofs. So why are we learning this? The experiment shown of a feather and an apple falling at the same rate in a vacuum chamber demonstrates Sir Isaac Newton's law on gravity and inertia. These laws are accepted as fundamental truth of physics. Some laws in geometry also must be assumed or accepted as true. Points, lines, and planes, a postulate or axiom, is a statement that is accepted as true without proof. In Chapter 1, you study basic ideas about points, lines, and planes. These ideas can be stated as postulates. So postulates, here, which is a clip from your textbook, you'll use all these postulates to do proofs. Okay? So you don't have to memorize all this, but you do need to know where to look in your textbook if you need to find this. Or you can make go back in this video clip if you need. Alright, so points, lines, and planes. So postulate 2-1, through any 2 points there's exactly 1 line. That's true. 2 points, there's only 1 line. 2-2, through any 3 non-collinear points, there's exactly 1 plane. So when you have 3 points, it makes up a plane. Okay. A line contains at least 2 points. So if you have a line, it has at least 2 points. It has many more, but the minimum is 2 points. A plane contains at least 3 non-collinear points. So a plane has at least 3 points in it. So 1, 2 is kind of parallel, well, same thing as going backwards for 2, 3, and 4. Okay? So 2 points, there's 1 line. In a line, there's at least 2 points. 3 points, there's a plane. In a plane, there's at least 3 points. If 2 points lie in a plane, then the entire line containing those points lie in that plane. So if you have 2 points that lay in a plane, then that entire line is also on that plane. 2-6. If 2 lines intersect, then their intersection is exactly 1 point. So 2 lines meet at exactly 1 point. If 2 planes intersect, then their intersection is a line. So if you have 2 planes going through each other, there's only 1 line that intersects. Okay, so all those postulates we're going to use to do some proofs. So architecture. Explain how the picture illustrates that each statement is true. Then state the postulate that can be used to show each statement is true. Line M contains points F and G. Point E can also be on line M. So line M, this line here, okay, contains points F, G. Point E can also be on line M. Okay. So which postulate is this? Let's go back. If you remember from 2-3, a line contains at least 2 points. It can be 2 or more, but at least 2 points. So it's postulate 2-3, which states that line contains at least 2 points. So this is the postulate we're referring to. Okay. B. Lines S and T intersect at point D. Line S and T intersect at one point D. So this is postulate 2.6, where it states if 2 lines intersect, their intersection is exactly at 1 point. Okay. So here's your turn, 1A and 1B. Okay. So go back on the video and tell me which postulate each one is talking about. Alright, welcome back. Analyze statements using postulates. Determine whether each statement is always, sometimes, or never true. Explain your reasoning. If 2 coplanar lines intersect, then the point of intersection lies in the same plane as the 2 lines. Okay, so 2 coplanar lines, they're on the same plane if they intersect. Okay, so if you need to draw it, we can draw it too. So on a plane, to coplanar. So there's a line here and a line there. That means both lines are on the same plane. If they intersect, then the point of intersection right here, that lies on the same plane as the two lines. So this is always true. Postulate 2.5 states that if 2 points lie in the lit plane, then the entire line containing those points lies in that plane too. So this is always true, according to postulate 2.5. Okay, excuse me. 4 points are non-collinear. Okay, is this true? So 4 points, they can be collinear if you put it on the same line. They can also not be non-collinear because they cannot be on the same line as well. So that's a sometimes. Sometimes they can be on the same line, sometimes not. Alright, here's your turn, 2A and 2B. Determine whether each statement is always, sometimes, or never true. Explain your reasoning. Okay, so if there's a postulate you can use for explaining your reasoning, do that. Okay, so go ahead and do numbers 2A and 2B. Alright, paragraph proofs. Paragraph proofs are exactly what it is. It's a paragraph proving. Okay, so making proofs through paragraphs. To prove a conjecture, you use deductive reasoning to move from a hypothesis to the conclusion of the conjecture you're trying to prove. This is done by writing a proof, which is a logical argument in which each statement you make is supported by a statement that is accepted as true. Once a statement or conjecture has been proven, it is called a theorem. It can be used to use a reason to justify statements and other proofs. Okay, step 1, list the given information and if possible draw a diagram to illustrate this information. So whatever is given, okay, you state that first. State the theorem or conjecture to be proven. Okay, so first you write the given. Okay, what is it you're trying to prove? Create a deductive argument by forming a logical chain of statements linking the given to what you're trying to prove. Okay. And then justify each statement with a reason. Reasons include definition, algebraic property, postulates, or theorems. Okay, you're going to use all that, and then state what you have proven. Okay, that's your conclusion. Alright, so what will this look like? Alright, one method of proving statements and conjectures, a paragraph proof, involves writing a paragraph to explain why a conjecture for a given statement is true. Paragraph proofs are also called informal proofs, although the term informal is not meant to imply that this form of proof is any less valid than any type of proof. So write a paragraph proof. Given that M is the midpoint of XY, line XY, write a paragraph proof to show that line segment XM is congruent to line segment MY. Alright, so what's given? M is the midpoint of XY. Okay, that's what they give you. Given, that's what they give you. And prove, they want you to prove this part. Okay. So if M is the midpoint of XY. Okay. So step 1 and 2, you state the given, and what are you trying to prove? Alright, steps 3 and 4, you're going to write in a paragraph. If M is the midpoint of XY, then from the definition of midpoint of a segment, we know that XM equals MY. This means that segment XM and MY have the same measure. By the definition of congruence, if two segments have the same measure, then they are congruent. Thus, segment XM is congruent to segment MY. Okay. So you're really just writing out what's obvious, okay? M is the midpoint of XY. So given the definition of midpoint of a segment, XM is congruent to MY. Right, here's your turn number 3. Given that C is between A and B, segment AC is congruent to segment BC. Write a paragraph proof to show that C is the midpoint of segment AB. Okay, so go ahead and write your paragraph proof and come back when you're done. Alright, last slide. Once a conjecture has been proven true, it can be stated as a theorem and used in other proofs. The conjecture in example 3 is also known as the midpoint theorem. So now we can use this theorem to consider according to the midpoint theorem. Okay, so M is midpoint of AB. That means AM is congruent to MB. Alright, so that's the lesson for tonight. Thanks for watching.